Okay, can you all see my screen? Can, right? It's a blank slide. Okay, so Heidi has a question from school. So all of you possibly have seen this question before. Yeah, and then let's explore together. So Heidi says, there's a question. It says 1.20 kg per meter cube, right? It needs to be converted to grams per cm cube. Okay, so this is density, right? Not we know it's density, because it's mass divided by volume. So you need to convert this to the required units. Answer must be left in 3 significant figures. Okay, so what do you do when you see questions like this? How many of you will panic? Evan, do you know how to do this? One look, you might be having a blank mind, right? Okay, slowly. Okay, let's do this slowly. Sometimes when you are suddenly thrown a question like this, you can get panicky. Okay, right, Savika? If I ask you now, hey, Savika, give me the answer, you're, huh? I cannot think leh. I just had dinner. All the blood is in my stomach, and my small intestine. My blood is not flowing to my head yet, can't think. But slowly, don't panic. What do we do? What do you understand by these things? It says, right, 1.2 kg per meter cube. Do you understand that this is actually 1 meter cube? Okay. In 1 meter cube, there's 1.20 kg. Yes or no? Can you understand this part? Huh? So you do the steps slowly. Now, I like to teach students to use this method. I know your school will tell you immediately multiply by don't know 1,000 or 10 to the power minus 3. Right or not? Your teacher will tell you that, right? I always teach my students to do this and they will never go wrong. How? So, Heidi, are you here? Okay. So 1 meter cube. 1 meter cube is actually 1 meter times 1 meter times 1 meter, right or not? Yeah. So I can actually even do the other side. The other side, 1.2 kg, you want to change it to gram, right or not? How do you change to gram? 1 kg is 1,000 gram, right? So 1.2 kg will be 1, 2, yes, very good, Heidi. So 1,200 gram. Can you all see that? Okay. So we change this meter to cm, okay? Because we need cm cube. So we always have to refer to the required units. So step by step. So I keep this part, don't change anything here. Can you see this? Yeah. So this is actually now cm times cm times cm. There are 6 zeros altogether. Can you see? I'm still going step by step. This is like mathematics, pure mathematics, So now I want to find 1 cm cube because it says per cm cube. Per cm cube, the meaning is 1 cm cube got how many grams? That's all. Okay? So in this particular side, right, all we are doing is we want to find 1 cm got how many grams? That's all. Clear? Okay, so similar like speed. For example, meter per second. If your speed is 100 meter per second, means what? Per second means 1 second. So in 1 second, I run 100 meter, that kind of meaning. So every time you see units like this, you can use the proportion method. Okay, so 1 meter cube, there will be 1.2 kg. So now I convert this 1 meter cube, right? It's volume. Volume, you know that you actually need to take the same unit, right? Multiply 3 times. So it's the 1 meter times 1 meter times 1 meter. That will give me 1 meter cube. Then from the meter, I convert to cm. Okay, so I make my life very easy by doing this. Heidi, you understand now? So there's no need for you to go and memorize whatever the teacher say times 10 to the power or what lah or etc. I always go back to the basic and I never go wrong. Okay? Can you key it into your calculator, Heidi? What do you have? Savika also try. Evan also try. Okay, you need to practice because in the exam, you are the one using the calculator. You better practice now so that you don't make any error. Okay, I have Heidi's answer. I want to see what you all have. So I want to see what Evan will get. Then Savika, you also type into the chat, okay? Okay. Savika and Heidi, same answer. Good. You must use arrow. You cannot say equal because meter cube is not equal to kg. You understand or not? This one is mathematical method. Will not go wrong one. You use arrow, you'll not go wrong. You use equal, you sure go wrong. Evan, you count the number of zero you divided. You key in 70. Do you realize? See? If I never ask you to practice, this will happen, you know? Okay. Yeah. So it's 0.0. Yes. 3 significant figures, children. One more zero at the back. 3 significant figures. Clear? So this is the answer, gram per cm cube. Heidi, is this the answer? Or you still don't know the answer yet? Oh, you still don't know. Okay, you go and submit lah. Wrong, you message me, okay? You got my number, right? Wrong, you message me and scold me. It's correct lah. Yeah, so this method, you will never go wrong. Clear? Okay. Today we are going to explore a separation technique. Many of the questions are still on solution, suspension, right? There's a little bit on separation. So let's go into the learning part first, which is about separation. Maybe I let you all see this first. When we are doing chapter 4, right? Okay, chapter 4, we are exploring diversity of matter using separation techniques. So what do you need to know when you are learning this chapter? Okay, so this is the syllabus document. You need to refer to this document. Savika, do you know this? Don't know yet, huh? Okay, Savika, this one is necessary because you need this also. Okay, you need this also to study for your exam, right? So this is from MOE. So you must understand when you are learning science in MOE schools, right? They have a certain set of requirement where the students need to fulfill lah. Okay, so you must learn about separation techniques such that you have the core ideas there. Okay, so the learning outcome after you learn what they expect of you. Okay, so you must have the core ideas to explain how constituents of a mixture. Constituents means what is inside the mixture. It's like the components in a mixture. For example, if I talk about sugar solution, the constituents will be sugar and water. All right, so it's a components inside the mixture. Okay, how they can be separated based on their properties. Yeah, so based on the properties, we have to decide which separation technique we're going to use. Okay, and then there are a few here: magnetic attraction, filtration, evaporation, distillation, and paper chromatography. You need to know these few inside the syllabus. Unless your school is going to teach you more from the Sec 3 syllabus, then let me know, okay? Drop me a note. I will give your extra notes to cover that part. Okay, otherwise, we just stick to what the syllabus says you need to know lah. Then state examples of the applications of various separation techniques in everyday life and in the industry. So you will also be talking about reverse osmosis. Okay, have you all been to the new water plant? Not yet. Okay, we have a new water plant, right? The new water, yeah, the bottled new water that you have maybe received from school before. National Day, they like to give out. Okay, so that is actually the recycling of water. Hi, Jared. So the recycle, they wouldn't say recycle, but they make the water drinkable again. And where did this water come from? They came from the sewage, actually. But we have such advanced technology that we are able to convert that into drinking water. And we are very sure that it's safe to drink. Okay, so don't worry about the new water coming from the sewage. It is entirely clean. Yeah. So you also need to understand what is the importance of separation technique in food safety. So when you learn paper chromatography, that will help you to identify whatever additive or whatever ingredients we add into the food. The Singapore government has done certain checks to ensure that there is no forbidden additive that is added that can harm our health. Okay, they carry out paper chromatography to identify those illegal substances present in drugs, in food, etc. Okay, now, so practices, okay, investigate separation. So it's about the same thing. Now, show appreciation, okay? Water is a precious resource, the need to conserve it. In history or maybe in geography, you would have learned something like this also, right? Geography, you'll talk about the water quality as well. I know because my son took Sec 1 last year. Now he's in Sec 2. So I'm very sure we all will discuss this in geography. Okay, so now let me go to the correct slide. Give me 1 minute. Let me pull out the slides first. Okay. Separation technique. Yes, this is the one. You all see now, my slideshow cannot play. The slideshow, you're giving me so many problems. Okay, separation technique. We have all these methods here, right? You saw just now in the syllabus document. Evaporation, magnetic attraction, filtration, distillation, paper chromatography. Now, you might not know everything yet, but just, give it a try. Okay, example, choose a separation technique for each of the following. The first one is on the drying of clothes. So you look at the separation technique that is listed above. Which one do you think can apply to drying of clothes? Something that we know since primary school. When you dry clothes, right, what were you doing actually? What do you think you were doing actually? Yeah, Heidi, you're right. Okay. So when you dry clothes, yes, okay, Evan. Savika, what do you think? When we are drying clothes, right, what are we trying to do in order for the clothes to dry? Very good, Savika. Okay, Jared, what do you think? You want to try also? When we hang the clothes up, we want our clothes to become dry, right? So what are we trying to remove?